My name is Oskar Kaplun. To those who do not know me, I will introduce myself in the next slide. Please don't be bothered by the picture. I wouldn't put that many protocols into one presentation, but it's just to give you an impression that we have plenty of things and you never know how many protocols you would need. They are called additional protocols, so they are basic protocols that should suffice for your implementations. But in case you need those additional protocols, it makes sense to use those which you need most. Briefly about myself, I'm working for CANopen for about 10-12 years. I have a degree in electrical engineering, supporting various technical groups at CANopen with developing of various specification, various application fields. Besides that, I'm also involved in standardization activities from the point of view of CANopen, motion control and low voltage switchgear at Siemens and IEC so far. I do also CANopen and CANopen FD testing at CANopen. So that is why I'm doing also the second presentation. The first presentation is because I'm also assisting exactly this working group. As my colleague mentioned, we have a working group for application, additional application layer functions and other additional protocols. We have a colleague of mine maintains and assists these groups so far about this. So this is the reason why I'm participating today. And in the next slide, I'll go on about the content, what I would like briefly to inform you about. Additional protocols, where do you start? A brief introduction, what are they? What do you need them for? And then we go into several of those protocols and services of CANopen FD in a little details to give you some information, give you some opportunity to see into it, either there is something for you in there or not. So I would tell a word or two about LSS, layer setting services, the network management of CANopen FD, network management of devices, how the network is started up, how it is managed in total, how to configure the devices and so on. Then also I will talk about the specifics of additional protocols. How do you upload or download firmware into your device? How do you start programs? What we're doing in this direction at CANopen for CANopen FD technology. Also some exotic and not that much exotic, but some very specific protocols and services, such as for high availability applications, mission critical like medical, aviation, that require always to be providing the services. That the key word for that is redundancy. So in any cases, the systems remain operational. This is also the working group we have. And in this working group, high availability, the redundancy concept is developed. I would say a few words about this as well. Other additional protocols, I would give briefly a few words about them because most of those are currently in progress of development. So the introduction. So we're talking about my colleague, Mr. Zitzman. My colleague and boss, Mr. Zitzman, has already introduced basic protocols, CANopen FD. With that, you could implement your server device. Please be aware, I'm using now in this slide also the new inclusive language used by standardization bodies and CANopen as well. We have a glossary for that. So I'm replaced all the terms related to the master and slave with manager and server accordingly. So whenever you find them, they are replaced, and you should be aware about this. So now back to this overview. What are the protocols and services we would like to talk about? LSS, as I said, network management, program download, and CANopen managing general management functionality of CANopen Manager capable devices, their protocols, what they are doing. Then is also a bootloader functionality. How do I convert my device into whatever device I need with a programming environment? Then it's the redundancy concept, the protocols and services for that, and the other protocols we might look into. So these protocols are well beyond the basic transport and error control protocols of CANopen FD. You find in a basic specification 1301. We have designed specification and other numbers. We cover these all protocols. Although I must mention that most of these protocols, except LSS FD, are in earlier or middle stage of development due to the new CANopen FD technology and the specifics we had to implement there and define there. So with LSS FD, you're starting actually the whole new thing for configuration of your devices and preparing them for integration into a system. It could be completely new devices, already existing system, you just want to reconfigure it. So the primary functions of LSS or layer setting services is actually to set up the device's address. Nowadays in CANopen FD, we have two addresses. It is node ID of the device, unique identifier, and network ID. This unique identifier of the device says about this network belongings. What is this device? Maybe is within the same network, but a virtual network within a network can be established, and this device can be also additionally distinguished from the similar devices having another node ID, but they're belonging to the same network, subnetwork within one and same virtual network. This is the reason for this. So we have now, in contrast to CANopen, second address called network ID. It needs to be configured as well, and LSS is actually the protocol and services we use to do this. And beside that, we have also beat timing that has to be configured if we reconfigure the whole network completely. Please don't mix this up with only bit rate. The beat timing is allowing to get the information to set up the controller itself, the CANFD controller, if you use then CANopen FD with CANFD. And this beat timing, a validation of the beat timing is done by these services as well. So what we do, what are the functions? Their detection, identification, configuration of the addresses, and the beat timing of each single device in the network. The first step in configuration and system integration of the devices. Second best thing it can do, stays you at your side, is to detect the devices in general in the network that requires configuration, and in general that have the capability to do so, and maybe even devices that are already pre-configured or lack this configuration whatsoever. That's two functions available and should be done in there. The properties are the functionalities that the specifics of the layer setting services, protocols and services that allow you to do some things. There is those specific things, sorry. First of all, we have designed a modern way approach. We design a structure of a state machine, finite state machine for LSS services, and we also specify which relationship when the validation of those addresses and configuration takes place in the relationship with CANopen FD, a network management communication state machine. So the LSS FD state machine is UML based. This is very detailed. We speak about it in the next slides. LSS in general has various services. We have limited those services, although we have the same, most of all, the same inquiry services such as those was available for CANopen devices. So you would say that certain migration is possible between CANopen and CANopen FD, and you will find almost similar services for configuration of the CANopen FD device addresses and bit timing. Beside that thing, we have unique identification of devices by their LSS address, is consisting of the content of the object 1018. Then we have operating sequences, says how do I handle the LSS configuration of device, how do I handle address configuration, identification, and same for bit timing. Then there is another feature available that we could use mixed operation of the frames within the same protocol to save some bandwidth and additionally use various messages for various purposes without to prevent certain irregularities in configurations. Besides that, there are also timing requirements. There are more strict timing requirements because of LSS, because of CANopen FD, bit timing, and there is also specifics for LSS FD performance, how quick the configuration takes place, how long should I wait till bit timing is validated. Such things are specified already. So, and finally, how do I handle, in shortly, if something goes wrong, if the protocol is wrongly implemented and some other things went wrong here. So back to this thing, as I promised, finite state automation, automaton, as it called, automata as it called, is the state machine, finite state machine, and it has two states as the CANopen version of LSS has, but is more cleanly defined here. We have a clear distinguishment what is going on as a transition and what is going on as a state itself. So we have state waiting and we have state configuration. State waiting, we have switches when you know what is going on. Is it still in a configuration or something, or it waits for whatever it might be happening within the LSS protocols and configuration services. So in configuration state, there are various protocols available for configuring, acquiring data, acquiring address of the devices, configuration of bit timing, and so on in there. And there is a third state introduced with CANopen FD to allow excluding devices which are already configured properly and do not need any configuration, or devices which are not configured whatsoever, and would prevent configuration using LSS since they are constantly involved in a process of the data exchange for LSS, and there is no way to turn them off. So this state, LSS passive, is especially to set the devices into this state. The state machine allows to do such things, but we need to know how to do so, how to configure it. The specification for LSS FD provides this information. And the very interesting feature provided today for identification of the devices in the network and helping to configure them subsequently is the introduction of the service with capabilities to making this identification. The service is occurred in state switch selective and allows to configure to detect unconfigured devices and to detect in general all LSS capable servers on the network. By helping with payload of CANopen FD frame for that case, we do not need to acquire the whole address of the devices called LSS address, which includes content of object 1018. There's vendor ID, product code, revision number, and serial number of the device. In this new process, it is possible to ask around in the network using only a portion of this whole LSS address, which in general can be transmitted fully with a CANopen FD message, since we have 64 bytes. But in order to increase the speed of detection of the devices, we just need a short chunk of information and send it around in the network and compare it with what the devices submit in return. So they confirm if they find out that they have the very same piece of chunk. As an example, we have a piece of vendor ID. This chunk contains information in various devices. Probably they come from the same manufacturer, and they contact the device acquiring this. This is LSS manager who does this. The other LSS servers and so on. They provide information. Yes, I do have this piece of address, piece of vendor ID. So in the next step, the LSS manager could continue transmit this information to confirm further rest of the remaining part of this LSS address, or may stop right there just for information to detect that in generally several devices are coming from the same manufacturer. And when the configuration is needed of the device, because the LSS address is used in configuration of the devices, not only in detection, it just needs this only small portion to know these devices have this, and they could strictly address these devices with these very addresses and knows which addresses they are, and communication, the detection of those and configuration of those could be done in very quicker way of doing things. For that reason, of course, this whole message was separated in an array of nibbles, so half of the byte. And so I can send a chunk of 4 bits to see how many devices confirm that they have this. I don't need to do a whole sweep using the whole address of LSS to detect the devices itself. Just a short information about LSS, you can see in the specification. I will talk about this later. Although you know the number of specification, where you could look into details of this profile, this specific protocol and services, such as LSS. And now I go in brief into some details on further services we needed. We talk about network management and a startup procedure. We need to start the whole network, including booting up all the devices that's called NMT server devices, booting also NMT manager who actually uses and manages the whole network, starts all these devices and monitors their error conditions and so on. Where we start? So we start at a startup process. That is what we're defining now. So this is work in progress. We have said we need some basic information. What the entity should manage the network. We have now specification 1301, which specifies also basics for network management, not only of the servers as former slaves, NMT slaves, but also for masters, which are called now managers. And in general, we do exactly go straightforward and say we have active manager, active NMT manager, and it should start up the whole network step by step. How we do so? We adopt the CANopen based version of it, is found in specification 302. But there are certain specifics of CANopen FD which we have to introduce there. So there's basically the process we are going on through in this working group, additional application layer. So beside that, we need to define all the processes with CANopen specifics, CANopen FD specifics in there, such as what is going on during the startup procedure, how the boot of each single devices are working, how the error control monitoring is working. Currently, we have only heartbeat as error control. That is why I've put the heartbeat monitoring in there. So it has to be handled. The monitoring of the total network, how it is actually find out what is going on there. The general error detection of the network, how does work up as well. And beside that, we have various devices, such as we have an NMT servers, an NMT manager, and we have in between some kind of devices, manager capable devices. They are formerly known also self-starting devices, but now we would like to add this under general definition as a capable, startup capable devices and so on. That is what we have to define as a process as well in there. We started with a modern approach. We design UML-based diagram, and first to know and allow our users, our members who start with this old stuff, to have some simulations of their networks in UML environment, how they could design and implement their processes and test them before that using such tools as UML in there. We use activity diagrams to describe the process of information flow in startup. We started with the active NMT manager. This diagram you can see is actually a snapshot from this. The second thing, how much of this information we have already designed for CANopen in specification 302. Should we adopt this completely or we redesign this entirely? So we're working on that. So we take some parts of this, but some protocols we separate for certain flexibility of usage. Next thing in there will be how do we differentiate in the future between CANopen FD and CANopen processes from the point of view of migration between both technologies. And maybe we have a joint pool of the functionality and we just switch between CANFD and CAN and see how much of this we can reuse in the network regarding of the startup of the network. How took a few steps where we go from that, where we started, where we continue, let's say. We have the parameter for this, which reflects the finite state machine, the status of the device and the configuration of the device as well. In regard of the startup, is this also option type of the device? Is this manager device, or is just simple server device, or is something in between? Does the device is capable of starting? And for this reason, I have provided comparison between CANopen FD based parameter. It is introduced also for servers as well, but you see many of the bits of this parameter 1F80 are reserved for other purposes. They are actually unreserved in case of NMT manager, and it is designed in different specification where you could use full extent of manager capabilities, but it seems their capabilities are not sufficient. We would introduce new parameter. We will have some additional functionality available, but it should be backwards compatible to the CANopen as well. And 1F80 parameter wouldn't be touched whatsoever. We just create a new one and awaiting the proposal for this reason. What we're going to do next with this protocol, yes, as I said, we have to do some things, have designed all the processes in UML-based diagrams, have to describe them, or describe what is from UML point of view means, what is from the process it means, what are relationships between the processes, how do I start up my network and so on. Then we need some protocols for the network startup, detection of the manager capable devices, such things we're developing right now. So the flavor, as my colleague usually says, of CANopen FD would be in this case firmware upload. So I have the devices, it has nothing in there yet, it has a bootloader, whatsoever kind, and I would like to download the content of the device that it should be then having some certain functionality. For that reason, we have defined a specification. That specification, and currently is work in progress. We're working on the manager, configuration manager functionality. We would introduce binary XML-based device configuration in there. And we have to define the formats and define the, not only format, define how this file goes into the device, how can we download it. So that is what I've put in this slide. Shortly, I'm a little bit over time, but I will keep it simple and short. This slide introduces the data stream as we see it now. This is a recent proposal. What is the structure of this binary file? It called shortly BOCE. How do we transmit? What information do we transmit in this file? And that we work on the formats for various transmissions, for various programs, which we could download in the device, not only necessary as a firmware, but also the program to start up on this device, depending on this functionality. Also, configuration validation should be in there, such as date and time handling. Such things will be defined in there. I'm limiting also this information for forward protocols to the redundancy, very interesting and important concept, especially for mission critical applications. It is based on already existing CANopen things, specifics we had in the past. It is removed for now because the usage was a little bit limited, but now we want to do this generically and having support for CANFD based networks, and especially should be CANopen FD compliant redundancy concept. We introduced a group, technical group, as my colleague mentioned, high availability, and this group works on this concept of redundancy to make this generic for all CANopen FD based and CANopen FD based technologies in this case. It includes, of course, the certain redundancy concepts, the communication interface redundant, the protocol can be redundant, the system can be redundant, the single device and network can be redundant. So, in this case, I would like to say a few words about this. It's the general concept as the diagram in there. As you can see, we have one application, address, node and network ID, and then we have several interfaces. One is default interface, another is redundant. I'm limiting the slide now for other protocols. We have various startups now, various groups also recently, for various activities we would like to do with different protocols, such as bootloader. We started generic bootloader that would suffice with a procedure. For every application, we have now the flying manager for devices, for systems that have multiple NMT managers and have to decide which one operates the network. We have also consideration about LSS manager, hierarchical networks, routing capabilities of due to USTO new features, power management, safety, security, and whatsoever other protocols. These groups which are currently maintained and working on these protocols can be seen found there. Welcome you to look into or ask us where to join, which group to join to have designers, and there's specification where you could find what we currently do with additional protocols. That is so far from my side.